So now we're to the point where we can actually draw some Lewis dot structures, or Lewis dot diagrams. We can use those interchangeably, or dot diagrams, for ionic compounds. So the first one that we're going to do is sodium chloride, which is Na, and then we have Cl. Now, to get started on this, you just learned about how to draw Lewis dot diagrams, and we're going to look at the group number to figure out the number of valence electrons we put on them. So what is NaN? What group?
Group number 1.
Group number 1, so he just gets 1 dot. All right, and what about Cl?
Cl is 17.
17.
But we can just say if we can just say that the 1's not there. So it's got 7.
Man, it's like you have this periodic table memorized. All right, so we have our 7 dots around chlorine. Now, you might have played a game. It was called None or 8. So we want one element to have no electrons left and one to have 8. Now, obviously, if you might remember from the rules, that the element that has less than 4 dots around it is going to be giving their electrons, and the element that's got more than 4 dots is going to want to take them, because we want to get to that magic number of 8. So we've got our Na as our metal, because he's found on the left side of the periodic table, and he is going to transfer his electron over there to chlorine. Now, the way this works is Mr. Thompson comes up to me and he says, you know, I don't know what it is about having $8 in my pocket, but it makes me feel so good. Miss Ressman, can I borrow $1? But I need that $1 in like 2 days to buy myself a soda. But he says he won't spend it. But I don't trust that Mr. Thompson, so I'm going to stay close to him so that I can watch him not spend my $1 and make sure he keeps it in his pocket. Similar thing that happens between sodium and chlorine. So now the way that we're going to write this to actually show that chlorine has gained an electron and sodium has lost an electron is we've got Na with a +1 showing that he's lost that electron, and then we have Cl. We're going to draw all of his 8 electrons around him with a negative charge. So we have somebody with no electrons and somebody with all 8. All right, so we've got the all or none or 8 idea down, right?
Yeah.
So let's try another one. We've got magnesium and oxygen. So when we bond them, they actually form magnesium oxide. So we need to figure out how many valence electrons they each have. How many does magnesium have?
2.
2. So we've got 1, 2, and oxygen?
Oxygen has 6.
6. 1, 2, 3, 4, 5, 6. All right, so again, he's got less than 4, he's got more than 4. So this guy's going to tend to do what with his electrons?
Get rid of them.
Get rid of them, and he wants to
take them.
Take them, all right? So, cool thing is, we can put one to this empty spot here, because remember we want to have pairs and a total number of 8. So if we transfer those all over, magnesium got rid of his 2, so he's got none now, and oxygen has a total of
8.
8, magic number that we want. So we've got none and 8. So we've got magnesium, and we said we lost how many electrons?
2.
2. So what do you think we should put as our superscript there?
+2.
A +2. Now, here's a crazy thing, guys. You can actually see this written as +2 or a 2+. Either one is acceptable. And then we've got oxygen with his 1, 2, 3, 4, 5, 6, 7, 8. And since he gained 2, we're going to write it as?
-2.
-2.
Or 2 minus.
Or 2 minus, either one.